Hi, welcome to my video on the product of monomial square root radicals. Let's look at the product of root A times root A. Examples: root 2 times root 2 is the root of 2 times 2, which is the root of 4, gives me 2. The root of 3 times the root of 3 is the root of 3 times 3, which is the root of 9, which is a 3. The root of 5 times the root of 5 is the root of 5 times 5, which is the root of 25, which is a 5. And the root of 11 times the root of 11 is the root of 11 times 11, which is the root of 121, which is 11. I don't know if you noticed, but there is a pattern to root A times root A. And the answer, root 2 times root 2 is a 2. Root 3 times root 3 is a 3. Root 5 times root 5 is a 5. Root 11 times root 11 is 11. So the pattern, root A times root A, is A. The product of the same two square roots is the radicand. That's under the root. So let's do these faster, because no need to write out. This is explaining all the steps up here. But what is root 6 times root 6? 6. Root 13 times root 13? 13. Root 7 times root 7? 7. Remember, when you do practice, you can pause the video, work out your answers, and press play back to see if you're right. Root 8 times root 8 is 8. Root 10 times root 10 is 10. Root x times root x is x, and we're assuming that x is greater than or equal to 0. Now that we have that done, what about the product of root A times root B? Well, let's check. We'll fill in this after. What's root 3 times root 2? Well, that's the root of 3 times 2. That's root 6. Root 5 times root 7 is the root of 5 times the root of 7. So that's the root of 35. Root 5 times root 6 is the root of 5 times 6 is the root of 30. Root 2 times root 11 is the root of 2 times 11, which is the root of 22. So as you can see, if you can notice, the root of A times the root of B is the square root of A times B. Okay. Practice. Practice means pause your video, work out the answers, and press play to see if you're right. That's the way I organize my videos. Root 2 times root 7 is the root of 2 times 7, 14. Now I'm not writing out the 2 times 7 underneath the root. Root of 11 times the root of 3 is the root of 11 times 3, which is 33. Root 5 times root 3 is the root of 3 times 5, which is 15. Root 13 times root 2 is the root of 13 times 2, which is 26. Okay, what about more examples? Notice that when we did root 2 times root 7, we get root 14. Notice there's a 2 here and a 7, they're primed, so the product is, there's no GCF as a factor. There's no perfect square factor. But let's look at these, simplify. Let's look at A. Root 2 times root 6 is the root of 12. But you notice that 12 is 4 times 3, because 12 has a perfect square as a factor. And the square root of 4 is 2, root 3. Root 3 times root 6 is the root of 18. And 18 is a 9 times 2, so it's 3 root 2. So a perfect square factor of 18 is 9. 5 times 10. Root 5 times root 10 is the root of 50. And root of 50 is 25 times 2, so it's 5 root 2. D, the root of 30 times the root of 3 is the root of 90. And 90 is 9 times 10. 9 is the largest perfect square, so it's 3 root 10. Notice as these numbers are larger now, watch what I'm going to do here. I'm going to look at, if I multiply 21 by 14, I get a large number. Then I got to break that large number down. So what I'm going to do is take 21 and write 3 times 7. And then I'm going to take 14 and write 2 times 7. Notice if I break these down into factors, then that's the root of 2 times 3 times 7 times 7, which means I have 2 7s, so I take 1, and I have 2 times 3, 6 left. So when the numbers get large, it's better to break the factors down first, like I'm doing here in prime factorization, and it's easier to do. Remember that. When the number is large, it's easier to use the prime factorization. When the numbers are small, like 18 and 50 and 12 or 90, then it's easy to do the largest perfect square factor. Practice, pause the videos, and work these out. Press play when you get them done to see if you're, or press play and see if you get the answers right. So, root of 14 times the root of 2 is the root of 28. And 28 is 4 times 7, so it's a 2 root 7. And the root of 3 times the root of 15 is the root of 45. 45 is 9 times 5. Square root of 9 is 3, so it's 3 root 5. And root 15 times root 5 is the root of 75. And 75 is 25 times 3. So that's 5 root 3. Remember, all the perfect squares up to 15 squared should be memorized. And the more often you work these out, the better you get. Now we got larger numbers here. So let's go the other way. Instead of multiplying these out, let's go 6 is 2 times 3. And go 22 is 2 times 11. So you notice that you have 2 times 2 times 3 times 11. So I have 2 2s, so I take 1. And 3 times 11 is 33. When the number gets large, it's better to go with the primes like this. 10 times 35 is 350, but trying to get the prime factorization of 350, you got to work down, so it's better to go 2 times 5 is 10, and 35 is 5 times 7, so you got to have, in order, 2, a 5, a 5, and a 7. So there's 2 5s there. The square root of 25 is 5, and what's left over is a 2 times 7, which is 14. That's the better way to go. Now, what about the product of x root a times y root b? Well, let's do some of these and work out. What I do, if I root 2 root 3 times 4 root 5, I go 2 times 4, which is my rational numbers or integers, and I go root 3 times root 5. So that gives me an 8 root 15. So I multiply the numbers in front of the radicals, and I multiply the radicals. The same here. I multiply negative 3 times 7, and I multiply root 2 by root 3. So that's the root of 21 root 6. And same thing here. It's negative 5 times negative 7 root 2 times root 2. So that's 35. And we know what root 2 times root 2 is. It's just a 2. So that gives me a 70. And we have these. So let's see what this is. So I'm going to multiply 8 by 3/4. And root 3 by root 6. So 8 is over 1. 4 and 8 goes 2. So that's a 6. Root 3 times root 6 is root 18. But root 18 is a 9 times 2. So that's 6 times 3 root 2. So the answer is 18 root 2. Practice. Pause your video and work these answers out to see how well you're going to do. Here we go. So let's, now that you know what to do, without writing it down at all like this, why don't we just go 4 times 5 is 20, and root 2 times root 7 is root 14, much faster. And negative root 2, negative 7 root 2 times negative 2 root 6 is negative 7 times negative 2 is 14. Root 2 times root 6 is root 12. And 12 is a 4 times 3. So the root of 12 is 2 root 3. That gives me 28 root 3. And we multiply this one. 1/4 root 10 times 8 root 2. 1/4 times 8. 2 and 8 goes, 4 and 8 goes 2. So that's a 2 root 20. But 20 is 4 times 5. So root of 20 is 2 root 5. 2 times 2 is 4 root 5. And number 4, 2 times 1/3 is 2/3. Remember, the 2 is over 1, so 2 times 1 is 2. 1 times 3 is 3. Root 15 times root 3 is root 45. The root of 45 is the same as 9 times 5, so that's 2/3. The square root of 45 is 3. Square root of 9 is 3. Root 5. 3 is over 1. The 3's cancel 1. So I get 2 root 5. And multiply this as a negative 1 times 7. So it's a negative 7. And the square root of 20 times 5 is the square root of 100. So that's negative 7 times 10. So that's negative 70. Sometimes they work out to be, without radicals, they work out to be integers or rational numbers. And number 6, notice I have 3 over 2 times 1/5. So 3 times 1 is 3. 2 times 5 is 10. Now if I multiply these, I get a large number. That's the large number is 600. So why don't I go like this? I multiply my two roots. So 20 is a 4 times 5. Let's use the dots for multiplication. And 30 is a 5 times 6. So that's 3 over 10. The square root of 4 is 2. I have 2 5s, so I take 1. And I have a root 6 left. 6 is left there. So that's 3 over 10. When I simplify this, I get 2 times 5 is 10, root 6. The 10's cancel, and I get a 3 root 6. Remember, you could have multiplied 20 times 30 and got 600. And 600 is 100 times 6. So that's 10 root 6. That's another way you could have gone. Or you could have broken it down like this. It's your choice. It's your choice when you're doing the work yourself. As long as you get to the final answer, just take your time. One step at a time. So a further explanation is what I want to get at here, is that if I multiply these two numbers, then I'm going to get a larger number. But if I multiply them, I get 10 times 15 is 150. Now I got to break 150 down. So why don't I break the 10 down as 2 times 5? Break the 15 down as 3 times 5. And if you look at it closely, I have 2 5s, so I have a 5, and I have a 2 and a 3 left, which gives me 6. Notice if you know what you're doing, then you don't have to write out 2 times 3 times 5 times 5. But if you're not sure, rewrite this step here to this one, and then go to this one. But it's your choice. But if you did the square root of 150, if you recognize that was 25 times 6, you would have got a 5 root 6. So, but when the numbers get large, it's better to go with the prime factorization. And as long as you can pick up a perfect square in one of the factors, then it makes it easier. So rather than go 24 times 18, why don't we say 24 is 4 times 6, because 4 is a perfect square. and 18 is a 9. I got a multiplication sign here now instead of a dot. So it's either or. But I broke 24 into 4 times 6. I broke 9 up into 18 up into 9 times 2 because there's perfect squares. So the square root of 4 is 2. The square root of 9 is 3. And notice, I still have a 6 times 2. So I got to go 6, but I got to break the 6 times 2 as 12, and that's a 4 times 3. So that's a 2 root 3, and comes down to my final answer. So you can go that way, or if you say, well, that's a little bit confusing, break it right down from the start. Take the 24 and go 4 times 6, and 4 is 2 times 2, 6 is 2 times 3. So 24 is 2 times 2 times 2 times 3. And break 18 up, and 18 is 3 times 6, which is 2 times 3. So 18 is 2 times 3 times 3. So if you put all them together, you got 1, 2, 3, 4 2s. 1, 2, 3, 4 2s, and 3 3s. Again, the dot is multiplication. This is the multiplication sign. So if I'm mixing you up, it's your choice. You can use multiplication signs or dots in between these. But sometimes the dots get confused with decimals. Just be careful. I got 2 2s. I take 1. I got 2 more 2s. I take another 1. I got 2 3s. So I take a 3. And there's 1 3 left over. There it is. That 3 is right there. So 4 times 3 is 12 root 3. So it might be easier to break it up into primes and then write them all down. As in 14 times 21. We'll break it down. 14 is 2 times 7. And 21 is 3 times 7. So altogether I have a 2 times a 3 times a 7 times a 7. So there's 2 7s, take 1 out. 2 times 3 is 6. Again, this step, if you know what you're doing, I got 2 7s. So when if I did this step, I would cross out the 7s and say they're gone, so I won't get mixed up. But it's nice to write this step down to make sure you're doing okay. Just be careful. Be careful of what you're doing. And if you like my video, click on the like button, click on the subscribe button, and the notification bell, because more videos coming your way. Write a comment on my video if you wish, and visit my math website, www.mathfullyexplained.com. I have a section on me, talks about my degrees and teaching experience. The section on video talks about the strategies you're going to use to help you learn your math. And the content section has the topics and the number of videos on the topics on my YouTube channel, Math Fully Explained. And the black font is what's online right now, and the red font are the topics that will be there in the near future. Thank you very much for viewing my video. Bye-bye.